All right, guys, let's get started. So today's lab, few reminders. Tuesday is your exam one. Okay, so it'll be the whole period. It's a written exam. Remember, you can expect about 10 problems or questions. This can be anything from an essay type question to, a cron entry, command pipeline, etc., right? Or a script. All right, so anything that we've covered from the beginning, Linux commands in general, and so on. Remember, it's closed notes. You need to come to class to take the exam. It'll be on Word, basically. You download a file and then we'll upload it back during that period of time. Okay, it's closed notes, but you're allowed your cheat sheet, right? An 8.5 by 11 page, and you can write whatever you want on both sides. Any questions about the exam?
We taking it like on the school computers or a laptop?
I would rather you take it on the school computer, to be honest. I mean, it's not like I'm gonna object to you taking, we're on the honor pledge, right? So, but yeah. Okay, any questions? Make sense? All right, perfect. So we started getting into the networking issues related to Linux, right? As you guys know, so you have quite a bit going on now with this set of labs. So I'm going to go to Brightspace here. I did grade your homework assignment, one of them. So you can check there your grades for that. Let me know if you have any issues or questions about it. You do have a homework assignment due tonight, right? Which is the cron, correct? All right, so if you have any questions about that one, raise your hand, let me know. So I'm just going to do a quick recap of where we are. Remember, this lab is not due this week. Instead, this will be due a week from Thursday, next Thursday. And I want to give you guys some time to study for your exam. Also, this is a big one, but I do recommend that you start working on it. Okay. So we are on this module, DNS. For some reason, as I've said in Linux sysadmin books, this is a big topic. It's a lot of detail there. So we'll implement this, configuring bind 9. That's something you just got to follow the tutorial very carefully. When you start configuring things in Linux, right, it's no longer a GUI. Right? Instead, you have to go in, turn on services, configure files, etc. Okay. So today, so we had started our discussion. So if you remember, the lab is this one. You have configured bind. That's part one, and then part two, configure some of the problems. So I'll probably take a look at this problem today. Problem one doesn't require bind, actually. It's just the etc host file that does the DNS resolution in Linux. And I believe we had started the scapy library also, which is a way that we can use scripting, such as Python, to interact with the network. Now, scapy runs it can run outside of Python also. So it is just a tool. Okay, one of your tools like Wireshark or TCP dump. Okay, so we've done, let's get started with that. I'll do some, continue the examples of scapy today. All right, so let me start up the virtual machine. There it is. So let me start the VM. And today I'm going to do a couple of scripts, sniff, spoof. These are things that you're going to need in other networking classes. So we're just going to take a look at how they work, and then a few other functionalities called scapy. I went over the lecture for DNS mostly. So I might do a review later. But yeah. And then, as I said, if you have any questions on any of the problems, I know these problems were a little bit harder, right? So if you haven't paid attention to them, the command line problems, have you guys started working on those? Command pipeline, okay, great. So let me know if you have any issues, but those are a little bit more involved. They're still one line type of questions, but they're interesting. So while it's loading, let me load up my notes. Okay, so VM loaded. All right, so everyone installed Scapy, as I remember. We had all installed it. All right, so once we've installed it, the first thing we want to try out, in this case, I'm going to just try a script. So I'm going to start up the terminal here. Right. Let's navigate to the desktop. Okay. So let's go ahead and the DNS scapy, so we'll use that. Okay. All right, so we're going to create just a simple script here just to get the feel for Scapy and how it works. And then, obviously we can start building up on this. So I'm going to open up Nano. Let's call this, example1.py. Okay, so the basic structure of this, I think we did a sniff before on the terminal, the Scapy terminal. Here we can do a simple script. So I'm going to do from scapy.all, and I'm going to import all basically. Okay, so we do the library, and then we can really quickly create a packet just by doing something like IP. So this works in a way that it builds a packet by default, and it fills in all the values by default, and then we can just grab a specific header and manipulate it if we want to, but we don't have to fill in all the values because they're all there, basically. All right, so that's the idea. So then I'm going to do a dot show. Right. So if we try this, we can see it creates a packet basically, and it's showing us the IP header. It just puts in some default values in there, like the source IP, the destination IP, and so on. Does this make sense? So this is just, a very simple thing. So for the attacks, I will show you another tool, because remember, we're doing some DNS attacks just to kind of get a feel for how things work with DNS. But you could also, instead of using the tool netwalks, you could also try and do scapy packets and attack it that way. Okay. So either way would be possible. At the end of the day, both the netwalks tool and scapy would generate packets basically. Okay. So any questions? I mean, it's pretty straightforward actually. If you were writing this in C, C++, it would be a little bit more challenging. However, keep in mind one thing, netwalks will be maybe a little bit faster because the underlying application is written in C, C++. Okay, whereas this is written in Python. Python, as being a scripting language, is not as fast. In the network, this is important actually. Okay, so keep that in mind for sure. All right, so we generated one, we ran it. You know, that's kind of just a simple idea. Okay. All right, so now we ran a sniffer. We ran a sniffer on Tuesday on the terminal, on the scapy terminal. Now I'm going to do the same, but just kind of in a script. So the idea here is you're starting to build up. Remember, if you have a script, you can run it with cron, you can do lots more things, and basically are able to get a lot of information, right? So, you know, a lot of functionality. You could build your own, you know, lots of things. All right, so let's go ahead and create another script. This one, yeah, sniffer. So when you guys take, actually the previous class, that's ITS 454, that's your network security class, right? So you will be doing a lot of, the concept of sniffing and spoofing is actually how you start with network security. Sniffing is grabbing packets, inspecting them. For what purposes? I mean, you could be an attack, you know, a bad hacker, whatever, and view data, right? But in general, you associate sniffing more with intrusion detection, firewalls, that kind of thing, right? But spoofing is actually when you take a packet, you copy it, manipulate it, send it back out. That's what the word means. It's just like the technical word, actually, although they sound funny. And basically that generates a class of attacks, right? Which are, as I said, I think I've stressed this before, they're not class attacks that exploit buffer overflow vulnerabilities or things like that, bad implementation of the software. In fact, you assume everything is implemented correctly. The key is it's trying to exploit just the vulnerabilities in what? In how the network works. You guys see that? And this is what hopefully you will see in the DNS attack lab. So we're not saying that bind has a vulnerability. It does not. Instead, we're just trying to see, okay, if we bring down the DNS, how could we trick somebody by sending out our own packets? Okay, so that's basically the idea. Got it? All right, so let's do the sniffer. So I'm going to just call it sniffer.py. Okay, nano sniffer.py. Remember, for this one to work, we'll need to get the pseudo privilege so we can get the interface, the network interface. So I'm going to do from scapy.all import all. And now I'm going to just exactly as I did before, you can define a function, call it, for instance, you know, this can be whatever you want it to be, print pk, let's say, or pkt, that's the convention for packets, right? And then this takes in a packet, basically. So pkt, colon, okay, just like that. And then for this one, we're going to keep it pretty simple. Just print the packet that we get. So I'm going to do 1, 2, 3, 4. And I'm going to do pkt.show. Okay, pkt.show. All right, then over here, I'm going to, you can invoke sniff, which is a built-in function in scapy. I believe by default, it does return a packet. So you can do it like this. But really, what's important here is that it takes two parameters. One is the filter, which is, I've said this before, they're all built on top of libpcap, so they kind of follow the same convention as Wireshark of the filter expressions. So I'm going to do here filter equal, and I'm just going to do ICMP. So we talked about this on Tuesday. ICMP means ping packets, basically. So we're going to have use the ping facility to try to get this to sniff. But we only wanted to print out ping packets. And then we use this argument PRN, which allows us to then pass to it the function that's going to process our packet. So in this case, print PKT. I'm going to go ahead and do that. Do print PKT, just like that. Got it? And that's it. So that's the power of this tool is really nice. So now let's go ahead and try it. Okay, so I'm going to do Python here. Let's try it without sudo. Okay, see, it doesn't, operation not permitted, permission error. So I'm gonna clear. I'm gonna go ahead and do sudo. And okay. So for this, I have to use Python 3 apparently. Okay, so there we have the program should be working, right? But it's not printing anything because of the filter. So how can we test this? I'm gonna try to open a new window. Oh, there it is, new window. Okay, and I'm going to just move this a bit. So let's ping something. Let's ping this machine, 127.0.01. I'm sending packets there. Let me ping something else. Let's ping 8.8.8. There you go. So I was internally sending the packets. When I send the packet, I'm receiving a packet. In fact, you can see right there, it mostly prints echo reply. Do you guys see that? So when you send out a packet, you have a type echo request. That's the ping packet that goes and makes the ping request. And you got a ping echo reply. Got it? So as you can see here, we are looking at a little bit more detail of what's going on in this packet. So you can see here, you know, all the data, echo request, echo reply. I think these are all the different packets, right? And it's got a payload, some of the parameters, ICMP, source, destination, all the information relevant to a packet. Any questions? All right, so pretty simple. That's a sniffer, basically. Okay. All right, so we implemented a sniffer. And of course, we can change this to have other filters, right? The function, of course, this function that we wrote over here could be a lot more complex, this one, than just one line pkt.show. So it can have a lot more detail, basically. Okay. All right, so that's the sniffer. We ping Google. Okay. And we're able to get some data out of it. All right, let's try something else. All right, so now we're going to get a little bit more specific, and it's going to be a little bit more challenging to get this to work. I'm just going to use the exact same script actually, and just change the filter over here. So still, we're just going to print. Okay, and then here in the filter, I'm going to do now TCP and TCP port, and we have to think of a port number. Okay, I haven't like settled on this one per se, but let's just say port 23 TCP and destination host and something. So I'm just gonna again just plug in some value 192.168.182.138. So remember, you have to think of how it's looking at the packet, right? So you have to think of scapy as looking at a packet, and it's gonna say, okay, is it a TCP packet? That's easy enough. All right, then what port number? Is it a source port, destination port? And then what host, right? So in this case, destination host. So if I did, maybe if I open a browser, right, and I go to a website, but then I would need to know the IP address of that website. I could do port 22. What is port 22? You did this last week, right? SSH. So let's say I'm going to try to SSH into something. What would be a destination host? What would be a good one? 205.215.116.11. It may not even need to exist, right? But we're going to try to trigger this by, sending packets that resemble this shape. Okay. Do you see what I'm saying, guys? And you guys can help me out. Fill in, with something that let's try an exercise, right? So what do we need for this? If I'm going to port 22, I need to SSH, right? And I'm saying that I want to SSH into 215.116.11. Okay. So then I'm going to run this one just as before. It's running. I'm going to go over here. Oh, this ping is still. Sorry about that. Okay, so let's move this one right here. So in Linux, you probably remember from the previous lab, you do SSH, right? That's the command for SSHing. You don't need PuTTY. PuTTY is more like a Windows thing. And from here, you can SSH into some machine. So let's say that you want to SSH into this local machine. Well, let's check to see if this is enabled first. So netstat-na pipe grep TCP. Okay, port 22 seems to be open, right? As far as I can tell, it's listening. So that means I can probably SSH into myself or into this machine. So I'm going to do clear. I'm going to do SSH seed, sorry. And then right? And then 127.0.0.1. Okay, there it is. So it's trying to establish the secure connection. Remember that SSH is encrypted. It's like Telnet, but encrypted. So you hit Y, and that kind of does the exchange of the keys. Say yes. Now it's asking you for the password. So in this case, this would be these. Okay. We're in. We were already in, but we're now further in. We went through a tunnel, basically. All right. So, so this is SSHing. Now, this did not trigger our sniffer. You guys see that? And that's because of the way that we've written the filter. Now, I want to exit out of here. So I'm going to see if I can do exit. You can see it says connection closed. So now I'm back out. Okay. So I'm going to try to trigger this because I'm generating these packets. So I'm going to go back. So maybe let's think through this one. So I think TCP port 22 should be correct. Where the destination host, maybe 127. We are going there, right? So you just have to think of the packet. What is in destination? Well, 127. So I'm going to try 127.0.1. Okay. Let's see if that works. Okay, it's listening. So now I'm going to try my SSH example once again. Okay. Looks like no luck. Okay. So this is probably needing something to come from the outside, I want to say. So let's unless you guys can think of another approach. I guess I'm going to try going to 888 again. Destination host 8888. I don't know that this will work though. I may need to turn on my other VM. Okay, I'm going to try that. I'm going to exit out of this. SSH 8888. Ah, there we go. It did work. Do you guys see that? So I was able to now, when I try to go to 8888, the sniffer picked it up. Doesn't matter if we get there or not. I mean, the point is that it should capture that packet basically. Okay. Any questions, guys? All right, great. So that is the example there of scapy. Okay, so that's another filter basically that you can use. Right, we could repeat this for Telnet and other tools, right? Telnet would be adding the 23, and then instead of SSH, you can just say Telnet generates the traffic and you try it out. Okay. That is the sniffing part. All right. Now we're going to try spoofing, right? That's the other element. That's more on the attack side in general. Okay, so we're going to try to just, as I said, I'm just going to generate a packet, and that pretty much should be it. Let me see over here. Yeah. All right, so for this, let's see. Yeah, so one solution here might be to start Wireshark, right? So that we can see the traffic. Otherwise, we could, we could run another sniffer, etc. But this is probably simpler. Okay, so ENP0S3. Okay, so there it is. It's capturing. I don't have a filter yet, so it's gonna capture pretty much everything. Okay. So Let's go to the terminal. Okay, so now. Let's write a script for just sending out one packet, okay? So how do we do that? I'm gonna do nano spoof .py. Okay. Same thing, we do from scapy .all import all. And then, as I said, the way that this works is you have these objects like IP, TCP, ICMP. So we're going to create an ICMP packet. So I'm just going to do A equal. First, I'm going to do the IP part. We don't have to define the Ethernet. It'll just do it by default. That's the beauty of this. So you just define IP, right? That's, you got your IP there. Now we can define some fields in here. So definitely we want to have the destination and the source IP. So in this case, I'm going to do A equal DST. Okay. And that's going to be the destination. So it doesn't matter. I'm just going to send out a packet because we're going to see it in Wireshark. So actually, we want something that we can visualize, right? So let's do 9.8.7.6, something that's easy to spot. And then I'm going to do a.source. And that's also going to be, let's say 1.2.3.4, right? So we're just going to create this packet and send it out. All right, so now we need to specify what type of a packet it is. So I'm going to say an ICMP packet. Okay, and now I'm going to, concatenate these two headers to create a full packet. So I'm going to say PKT equal, and it's very easy. You just do A/B basically, and it's like you're piecing it together. If you had payload, for instance, payload, something like that, you just sequentially add them up. But in this case, I'm just doing A/B, and then we can take advantage of a function called send that's available from the library, and then we can just do PKT. Okay, so with this, we should be able to send one packet and pick it up with Wireshark. So I'm going to do Control X. All right, let me go back here. I'm going to clear this. All right, so it's listening. Okay, and then we should be able to run this one. Okay, I have to do that Python 3. Okay, sent out one packet, it says. So let's go to Wireshark, and you guys can see it. It's right there, right? So we have a source 1234, destination 9876. So we were able to instantiate this packet basically and send it out. So this is the basis of an attack, okay? So obviously, the challenge for the DNS attack lab, this shows that you can send out a packet. But now you would need to construct it in such a way that it has all the fields necessary to fool the DNS, either the DNS client or the DNS server. That's the key, you see. So the other tool that we have in the PDF is something called Netwalk. So that's the other thing I'm going to show you today. It's easier in a sense to use the Netwalks tool because that's for a specific attack. So it's really almost like you just pick that you're doing a DNS attack, you specify that number, and then you plug in a few fields. If you want to do it through this approach, as I said, the key is you have to go into the code here, right, and fill this up properly. Either one you know, might take it as a challenge. I'm really just asking you to use netwalks, but you can try this approach as well. Any questions so far, guys? Making sense? All right, so we did a spoof example, and we generated a packet that went out into the network. We saw it in Wireshark. It's there. Okay. Now, the next step I'm going to do is I'm going to combine both the sniffing and the spoofing into sniff and spoof, right? So this is usually what, you know, here we just generated a packet, and the other one we were capturing packets. Usually an attacker would be like listening, so they're sniffing, grab a packet, create a copy of it, change it, spoof it out. Do you guys see that? That's kind of what the DNS, when the second attack is going to try to do in essence. You know, it's going to be, you know, sniffing in the network. When it sees the query request, it's going to capture it because it's going to meet the filter expression. It's going to make a copy of it, modify it a little bit, send it back out. So that's what we're going to implement now. So I'm going to create the third script, sniff and spoof. .py. Okay. So you can see it's, you know, we're just I'm basically just going to combine what I've done before to create a new one. Okay. And this just gives you an insight into how this works in the underlying code without having to look at the C code. All right, so let's go ahead and define, think about it, think through it. So it should be same library from scapy, scapy.all import all. Okay, you got that there. Now I'm going to basically have the same function as before. And really what the key is what's happening here. So I'm going to do spoof PKT. Okay, so this takes the default packets, colon. Okay, 1, 2, 3, 4. I'm just gonna end it with send for now. We'll come back to this because this actually has a lot of code. And then I'm gonna go down here and I'm gonna do PKT equals sniff. And then obviously the filter expression is, oops, sorry. The filter expression here is really important. Okay, so this will be what? Let's just keep it as ICMP for now. All right, so whenever there's an ICMP packet there, it's going to trigger and it's going to invoke PRN, right? And it's going to invoke spoof underscore PKT. All right, so this is basically the mechanics of it. It listens for ICMP packets. It grabs that in PKT. It goes to the function spoof PKT, which is this one, sends the packet, and now it's going to send it back out, right? So the attack is triggered by capturing a packet in sniff and sending something back out. So now here we can do, for instance, print, and I'm going to stop this DNS thing or the Wireshark thing. Okay, so let me go back to the code. All right, so I capture the packet, PKT, so I want to print something about it. So I'm going to do PKT. And then from PKT, notice I'm going to specify which header I want by just doing that. Does this make sense? So remember, I have the whole packet here. the whole ICMP packet, the ping packet I just captured, and I want to get just the part of it that is the IP. And then I'm going to print out source and destination, which should be available in that packet. And then I'm going to do print PKT, also IP, and then destination, which is DST. Make sense? Let's not forget to close. And so this basically effectively sniffs the packet and prints out values from its IP header. Okay, that's specifically, we could also print all the information. So by the function we've already seen several times, PKT show. So you have that available. Okay. All right, let's move down here. So now we're going to get a little bit more into like the guts of it. So what do you want to do? You want to now spoof a ping packet, right? In a sense. So let's create a variable A, IP, and now we're going to flip around some values. Okay, so I'm going to say that now I want my source IP to be what? The packet's destination IP, right? I'm flipping them. So it's going in that direction. Now it's going to go. So you flip source and destination. So I can do that already by trying PKT IP dot DST. Do you guys see that? And obviously I do the same for the other one. DST is going to be equal to PKT IP dot source. Okay, and then finally, there's other values that we can, it might need for this to work. So there's a, if we, there's an IHL parameter. So that to have a proper, spoofing of a packet, we would need to include that, right? So in the IP header, I'm just going to copy literally. Oops, sorry, this should be it. Do you see that? So I'm copying from the packet I grab a value and I'm assigning it to the new one. Does that make sense? This is a lot easier than creating the DNS packets for the attack because there's maybe more parameters. All right, so other things. So that was just the IP part. Now, because this is a ping packet, remember it's going to have an ICMP header. So let's go ahead and invoke ICMP. Okay. Once again, we need to specify. So ICMP packets have a type, and I think it goes from 0 to 8. You guys have to look at the description of it. I believe 0 is an echo reply, and 8 is an echo request, or maybe vice versa, right? So we need to like play with that. So, but you can specify a type. Oops, sorry, this should be lowercase. So type equals 0. Okay, you see that? How we can start to define the fields in the packets. And then this has other parameters like the sequence number. So that means you captured a packet, ICMP packet, it had a sequence number. In your spoof packet, you need that sequence number when you send it back up. That's the idea. All right, so I'm just showing this. I'm not doing any specific attack per se here. I'm just showing you how to, the basics of it. So sequence PKT, oops, sorry, PKT, all right. Now this sequence number needs to come from packet, but obviously it needs to come from where? From the ICMP header, correct? So I'm doing ICMP. You see how easy that is? So from the packet, now I'm accessing the ICMP header, and I'm just going to copy the sequence number. Some cases you need to do things like add a, so you increment the sequence or something like that. So you can do stuff like this, right? But in this, we're not doing anything that complicated. And then you might need to have the ID from the ICMP packet. So I'm just going to go ahead and do ID equal PKT And then once again from the ICMP header, and I'm just going to say .id basically. Okay, this is just an example. I'm spoofing, which means I'm copying fields from the one I just sniffed, replacing them in my new packet, and I'm going to send it out. Notice also that these packets have data that they carry. In fact, it's interesting how you can put data in ping packets and actually like communicate with your friends all over. All right, so we might do that. We might play with that a little bit. But in particular here, we're just going to add that data back into the packet. So I'm going to now create the new spoof packet that I'm sending out into the network, PKT. And I'm going to create the packet itself, right? So that's going to be A/B/, and it's the packet itself has data. So I'm just going to send it back out. The data would be in something called raw, okay? The packet has the Ethernet, the IP, the ICMP, and then the raw. And that's what I'm copying back in. Got it? And I've spoofed the packet basically with scapy. All right, so I can go ahead now. All right, and I can print things out from this new packet just so I can view them. So I'm going to do print. And I'm going to print out new PKT. And then from IP, I can view, for instance, its source and destination. I'm going to do that one. I'm going to do this one. I do new PKT IP dot DST. All right. And now the packet should be formed. And all I need to do is something we've done already, which is send it back out. If I remember correctly, so as new PKT, if I remember correctly, the send function has a counter, which I think is probably counter. You can set this to that. Do not send that. Do not set it to that and send it into the school's network, right? But, or you could just do a for loop. Either way, by default, it's 1 though. Okay. All right. Got it? All right. So we should be able to have, hopefully this will work. This is, as I said, it's just a simple example. So I'm going to need to ping. I did ICMP here. Okay, let's try it. So I'm going to do Control X, Y. I only have one VM here. So this would probably be better with 2 VMs. But let's go ahead and try this out. So sniff and spoof, right? So it needs to run in the background. Sudo Python 3. Okay. No errors. So it is running in the background. Now we need to trigger it by running some type of, let me start this. Okay. And let me try the terminal. Oops, sorry. There we go. Go back to the terminals. So it's running there in the background. I need to go to the other one. This one. Okay. So I need to trigger that. I'm going to do ping 1.2.3.4. Okay, so it's pinging 123.4. That IP exists, doesn't it? Does that IP exist? You're not getting anything? Let me try. Let me kill the attack, right? So, all right, it's killed. So there's no sniffing and spoofing. I'm going to do clear. Oops, sorry, clear. I'm going to ping 1.2.3.4. Do you guys see that? Do you guys understand what just happened or no? what am I doing right now with the ping facility from one terminal? I'm trying to ping 1.2.3.4. Do you guys see that? But that IP does not exist. It's not an actual thing. So I'm getting no replies, right? When I turn my sniff and spoof, notice what the interesting thing then happens. It's, yeah, so ping is sending out packets. You know, ping 1.2.3.4, but there's no such thing in the internet anywhere. And so nothing happens. It's just hanging there. But if now I'm going to kill it. All right, so I've killed it. Now I'm going to start sniff and spoof. Sudo Python 3 sniff and spoof. See, it's now listening. It's looking for packets that are ICMP. Whenever it gets a packet, it's going to flip it and becomes a response because I changed the type to 0. So if you notice, now it is running. I'm going to ping 1.2.3.4. And guess what? It is almost as if it is there when it's not there. You see, this is an attack in the sense of network security. Why is it an attack? There's no vulnerability in any of this, but it's just exploiting the way that the network works. And it's creating an illusion that there is a 1.2.3.4 when there isn't. So that's what I meant by this class of attacks. Got it? Any questions? Obviously, this is like the easiest attack that you can do. You can do way more the DNS one would be almost exactly like this, except you need to make sure that you got the right fields correctly set up. So I leave that as a challenge for you guys if you want to try it out. The next thing I'm going to show you is how to use netwalks, which is you can use netwalks kind of to guide you to build this attack with scapy such as this. All right, so as you can, hopefully that made sense, right? You guys understood. So we did a sniff and spoof attack and just illustrated very straightforwardly how you can sniff, capture a packet, take the fields, create a new one, send it back out into the network, and we've created insecurity in a sense. So that's the internet for you. All right, so not hearing any questions, so we can proceed most likely. All right, so let's go ahead. So we did that. Okay, keep going. So we did the ping, sniff and spoof. All right, let me just see if I have a little bit more. All right, so yeah, so the next step is I'm just going to do a few additional commands with scapy, kind of wrap it up, right? So I will be wrapping up scapy, and then we'll come back throughout the semester. I will consider, this is like a demo of it, and then you guys would know how to use it. So then we'll just come back whenever we need it. All right, so let me just go over a few more. Check my notes here. All right, so I'm going to clear here. I'm going to stop the sniff and spoof code. Okay, so that's been stopped. We went over when we were doing, we went out over LS, so we can see everything that's available in scapy. We've done the sniffing with a lambda function. So let's see, this one. It's kind of interesting. Let's say that you wanted to communicate with your friend via ping. right? It's possible, right? You ping them. If you ping a machine, you're going to that machine, right? Something on the internet, obviously. And if they have there a sniffer that's printing everything that comes in, the message that you're sending across should print out, right? So let's try that. This should be a fun example. So we want to say hello to someone, right? So hello something. So how do we do that? So we got to think about this one, but hopefully it'll be easy. So this would require us to send. So let me see which one of the scripts we can use. So probably spoof. Let's just use that one. Go. Okay. So now all we would need to do is we need to basically append here a message, right? So we know that we have an IP address. We know we have an an IP header. We have an ICMP header, and then the raw goes here basically. So maybe it'll be just as easy as doing hello. Let's say hello Google. Okay. So then we need to send it to Google, right? So that's going to be 8.8. Do you guys see that? Do you get the basic logic? The source doesn't really matter. In fact, what are we doing? I mean, denial of service attacks have random IPs as the source. We only send one packet. So let's try this out. So we have a Wireshark here, right? So that Wireshark is listening. Okay. So let's go ahead and run that one from the terminal. So let's try it. So I believe it's correct. Okay, we're going to run spoof. Okay. So we need to do sudo python spoof. Oh, Python 3. Sent out one packet. I can see some traffic here. There it is to 888. So let's hello Google. There it is. Do you see the message? So we effectively have used ping to send out some data to your friend. It should be obvious, right, that if you have a sniffer on the other end, when the packet is captured, the data is received, correct? Pretty easy. Any questions on that one? All right, great. So you have a very, very easy way of sending communication to anyone in the world. All right, so now, so we've done that. What else do we have? You also had TCP dump, right? So you guys could turn on TCP dump and basically use it that way to see the data, the hello Google. All right, so this one. So there's a functionality here to do trace route. So let's try it. Oops. Okay, I'm gonna need to install a library for this. So let's see if it works. So we're gonna try to do a trace route, capture the data, and then basically visualize it. Okay. So I'm going to go back into the terminal here. Okay, so I'm going to try to install a library. So I'm going to do sudo apt get install in something called image magic. It's a library that should work with scapy. Let's see. Okay, so it's going. We have to look to see if there's any errors in the installation, right? Okay, so let's give it a minute. Okay, so I think it finished. I don't see any errors. Let's also install sudo apt-get install graphviz. Okay, once again. Okay, hit yes. Look at the output. Make sure you don't see any errors. Okay, it finished. Now let's start scapy and run it from the command line. So I'm going to do sudo scapy. Okay, remember that. Oh yeah, sorry.
What was the second one to install?
Oh.
First one still installed.
Yes. Oh yeah, sorry. The second one I installed first image magic, and then I installed graphviz. And these are just two libraries so that we can visualize some of the networking data that we're going to collect in a sec. So these just are visualization tools for scapy.
Wait, how is that second one spelled?
Graphviz, Graphviz.
Thank you.
Yeah. I'll leave it there for a sec. All right, so I think everyone is caught up. So I'm just gonna illustrate with the famous trace route. So this is basically trace route as you would do it, you know, for your own tasks. Let's just try here. Okay, so I'm gonna run a trace route. Oh, I need to start scamping. Okay, there it is. So the way that it should work is let's do a trace route from here. These are the variables that are going to capture the results. Okay, so unanswered and res. Okay, we invoke the scapy has a trace route function as well. Right, so it's got basic networking things associated with it. And we're going to trace route a list of domains. Okay, so we can go to Microsoft.com, for instance. And these should be in double quotes. We go to www.microsoft.com. Okay, what else? Cisco.com. And you guys can try, anything else that you want to do. Cisco.com. Probably let's go to pnw.eu. See, I think PNW is a little bit less restricted with things. And you guys can try another one, whichever one you want. All right, and then we need to specify a few ports, or if you want to specify a few ports, you can by doing, D port, and then specify like you want to go to port 80 or 43. So we're going to web servers basically. You can specify things like the maximum TTL, so time to live, which is how traceroute usually works. Did I? What happened here?
Mine is doing that too. It's when you,
I went over, right?
yeah, you can just zoom out.
Okay. Am I zoomed in? Is that what it is? Okay. Thanks. Yeah, there we go. Perfect. Thank you. All right. So, max TTL. So the time to live, max TTL, right? Which is how traceroute works. So put in a value like 20, and you can set some parameters such as retry. And let's just use a default -2. So maybe it means it'll retry it twice or not retry it at all. All right, so I'm going to do -2 here. All right, so let's see if it works. So I'm going to hit enter, begin emission. So basically finish sending 120 packets. It went to all these places, right? And it collected some data. You can see there it's got some different IP addresses. Okay. All right. So let's now the idea with GraphViz is a tool to visualize. So here you see results of the traceroute command showing the different hops that it took to reach the destinations. So let's see if we can graph this a little bit. So then the data should be in res. So then you should be able to do, if this works, res graph. Like that. Res graph. What did it say? Enable trace malloc to get the object allocation trace back. Okay, so it generated this. Yeah, I'm gonna open up. Okay, so this is Image Magic. That's the basically like an editor that it's got. I think. It's not generating very well, is it? I'm going to close Wireshark here. Okay. I'm going to let me try run this again on just PNW. Okay, so let's try it out. So it did the trace route there, 40 packets, got 40 answers. Now let's see if we can't do the rest graph. It doesn't want to. It gives us some information to Purdue University, but it's not doing everything. Are you all getting this the same thing? Yeah. Okay. Enable trace malloc to get the object allocation transfer. All right, let me run this again. I'm going to save that command. Okay, so I'm going to do exit. Okay, I'm going to clear this. I'm going to start scapy again. Okay, this time I'm going to try let's trace. Let's see. Actually, that's a warning, so it shouldn't be an error. All right, so let me try. All right, so it gets the data. Res dot graph. But it only gives me this. 128, 210, 7, 200. 128, 210, 7, 200. There's nothing here. Oh, okay. You know what I think it is? It's just the data is only that. For this to work, it probably the computer needs to be in bridge mode. I have a feeling that's the issue. Do you see how the data is all the same IP address, correct? Right? You guys see another one in there? And that's why it's only plotting. There were 128, 210, 7, 200. Yeah, so it's not, I think this only works like when this is a local machine, not a virtual machine. So what you can do is actually, we put this in bridge mode. Maybe it'll work. Let me try that. Have you guys tried putting these machines in bridge mode and got it to work? That can be a little bit tricky. So I believe I have a feeling that's the problem. Let's see. Device, network, right? Network settings. VirtualBox, so bridged adapter or host only adapter. Let me try this bridge adapter. See if it works. See if we can get an IP address first. Clear. ifconfig. Says 10.024, but if I ping 8.8.8, see it's not connecting. Oh, no, it's not. Yeah, so that's the issue. I put it in host. Time. Right. Let's see. Yeah, I'm unable. I'm gonna take it back to Nat, but I think that's the issue. I usually don't put these machines in bridge mode, the VirtualBox. So I don't know if you guys have tried that and got it to work. So bridge mode means that you would get an IP like this is a physical machine from the switch, but that configuration is not something I have. So now we are 192.168. What did I give it? Oh, I did NAT. Well, let me try NAT actually. Oh, I'm back at 10. Okay, so did I put NAT network in there? I'm using NAT. Let me try that trace route again with NAT. Like I said, I do believe it's that. Let me try scapy. And then let me try trace route. Okay, some of these it started, right? This is different a little bit. Would you agree that there's like two? So let's see, res.graph. You can see it now did for the data that it has a little bit more. Do you guys agree? So if it had more data, it would show more of the hops. Here it's only showing this 10.022 and then that 128.210.7.100. I don't know if you guys see another IP in there. So that's basically what is happening. I'm pretty sure, like I said, if you try this on a physical machine, or put this in bridge mode, you should be able to get it to work. Okay. Where was that graph? Oh, here it is. So you can try this, play with it, but it should be able to give you more information. I mean, if you have more IPs in here. Well, that's great. Now there it is. So it goes from 10.022 to 128.210.7.100. So it's got both of them. Anyway, I've spent too much time on graphing this, but basically it's just a functionality for trace routing and various other tasks. All right, so let's do, I'm gonna close all of these. Okay. All right, so that was, I think that's pretty much scapy, just to give you a quick overview of how it works. Now let's go back to the lab and talk a little bit about netwalks, which is, so hopefully you'll understand more netwalks, which is basically like if it was sniffing and spoofing, as I just showed, but we're doing it on just one command line. All right, so I will exit out scapy. I'll leave this open. So the next tool you want to check to see if you have available is this tool called netwalks. Okay, there's also a netwag like this. Okay, so let's try netwalks. Okay, as you can see, there it is. This is the network security attacks tool. It's got a main menu basically, and you can see it's got several built-in things, like it can, You can sniff basically, which is what I just showed, which is capture network packets. You can spoof, create and send packets. Ping, basically trace route, which we just discussed, scan, brute force, check if passwords are weak, a network audit, and so on, right? So it's got functionality, but beyond this, it's got this set of commands, like several, and they're basically attacks. And so what it does is it spoof different kinds of packets depending on the attack that it's going to try to do, okay? So let me take out the charge, right? Right, so we're gonna go back to Brightspace now. Go back to Brightspace over here. Okay, and we're gonna go to the table of contents. Okay, and now let's navigate to the module DNS, right? So this is the DNS module. And we're gonna take a look at the PDF that is basically the assignment for you guys. Okay, so I'm gonna take a look. So as you can see, this is the DNS DNS server configuration and then attacks lab. We've discussed already the scapy tool, packet sniffing and spoofing. All right, you know at least how to spoof an ICMP packet, but the challenge is to spoof a DNS. All right, so next Thursday, we're gonna have to configure the DNS server with bind. So I already talked about the setup. So today I'm just really focusing on this sniffing and spoofing part so that that's out of the way. But yeah, we'll talk about configuring bind next Thursday because we're going to need that for some of the attacks. Then we get in here, attacks on DNS, right? The first one is pretty easy. This one, task 4, it just uses the etc host file, so it actually does not need really anything. But the other two will require us to send out packets into the network. So you can see now it starts to talk about the fake DNS response. Those spoof packets will be accepted by the user's computer if it meets the following criteria. So the source IP must match the IP address of the DNS server. The destination IP must match the IP address of the user's machine. The source port number, UDP port, must match the port number that the DNS request was sent to, usually port 53, and so on. Okay, so you can see it starts to talk about all these fields, basically. So here it is. This is the sniff and send DNS answers, but instead of using scapy, we have this other tool called NetWalks. NetWalks has a series of attacks, and they have numbers, basically. Okay, so for DNS, it's going to be NetWalks 105. Okay, make sense? So this is the tool that you will need to use, and then basically you just specify these parameters. Okay, so you can see like there's a filter, just like I showed you that there was a filter in scapy, and then there's going to be some additional information that needs to fill that. Okay. So that's basically the idea with this lab of DNS. Right, so that will be the challenge, basically, is to run NetWalks. So that's going to be NetWalks, what is it, 105. All right, so let's go back to the VM. Okay, so I'm going to do this. And now it would be NetWalks 105, but we need to still specify all the fields that go in here. Effectively, it's like if we were doing this in scapy, it would be very similar. Okay. Just looking for the commands. Yeah. And we'll wrap up with that today. Yeah, this took a while. Sorry. All right, so the command is something like this. Okay, I'm not gonna give you exactly, but netwalks. Obviously, it would be sudo because once again you're spoofing packets, so you need the interface. Then -h is one of the flags. You need to specify some domain here. For instance, it'll depend on the attacks, but it would be like this is in the context you have to read of the problem, but it would be like bank24. Okay, just as an example of how you populate this information.com. Remember, you're spoofing, so it's gonna insert something fake in there. All right, then you need to specify an IP address also, -h. So in this case, the field would be populated like this. So I'm just going to put in, you know, an IP address. Okay. I'm giving you mostly like the syntax. Then you specify the DNS that you're impersonating. So -A, and it would be ns.example.com. Remember that you're going to be using example.com as the domain. And then you need to have the IP associated with the network. So this would be -A, and then this is going to be an IP address. You guys need to fill in all these values as part of the problem based on your setup, okay? But these are the fields for sure. And then the final thing is -F, which probably you can see it stands for filter. So you're going to put in here src source and then some IP address. You guys see that? So something like 10.0. Let's say .2.14. Okay. So this should be the usage basically of networks. Okay. We will come back to once we have the problem. I won't give you these parameters, right? But you just have to fill them in. So whatever's in double quotes, you can fill it in with your value. Any questions on this one? That's it. That's how NetWalks works. You hit enter and it runs basically. And it's gonna do what I did with scapy, sniff, and spoof, essentially. Okay. So that's that part. There's gonna be 2 times that you run NetWalks. This is for the first one when the server is down. And then there's for the last problem where you want to poison the cache of the DNS server. You also run NetWalks. For that one, the command is a little bit different. So once again, I'll give you, so everyone got this, right? This is the command for one of the problems. Okay, you just have to fill in the fields. And then now I'm gonna give you the command for the final problem. I'm gonna reuse this one actually. I will add that you should have sudo in here. So sudo, it's still netwalks 105 because it's a DNS related attack. Still you use -H, uppercase H, the -A is there, lowercase. The -A uppercase is also there, the filter, but this one just needs to have a few more flags. So you're going to say -S raw -T, oops, dash uppercase T, and then 600. And this is the other attack, okay? The other type of DNS attack to poison the cache. One impersonates the DNS server, one actually poisons the cache of the DNS server, okay? So these are the commands as they are, and of course you will have to figure out how to fill in these values based on your, although some of these are probably correct, like this one. Okay, so that's kind of what I wanted to cover for today, just give you an idea. I think there's only one more tool, which is the NetWag tool. So I'm going to try to start that one. You probably need sudo too. Yeah, there it is. So this NetWag is like the GUI version of NetWalks. So you can play with it maybe. One nice thing about it is you craft the attack as you want it, and then it generates the syntax to run in the terminal. So then you could just copy that syntax and run it off the terminal. Okay? This will be for the 3 problems. So yeah, so that basically concludes scapy and talking about sniffing and spoofing, some of the background. Next Tuesday, remember, is your exam. And then on Thursday, we're going to get into the actual, this lab, right? So we need to configure bind and then start doing some of the attacks, basically. Got it? Any questions? All right, so that's it for today. Don't forget the exam, please.